Have you ever felt your ears pop when you dive deeper into a swimming pool? That feeling happens because water pressure increases as depth increases. In science, pressure means force acting on a certain area. The basic formula is pressure equals force divided by area, or P equals F divided by A. This means that if the same force acts on a smaller area, the pressure becomes greater. But liquids are special. A liquid does not only push downward, it pushes in all directions. It pushes down, sideways, and even upward on objects inside it. That is why a balloon filled with water expands in every direction, not just at the bottom. Now let's look at the formula for pressure in liquids. Liquid pressure equals density times gravity times depth, or in symbols, P equals RHOGH. Let's break it down. P means liquid pressure. Rho means the density of the liquid. Density tells us how much mass is packed into a certain volume. A denser liquid produces more pressure at the same depth. For example, salt water is slightly denser than fresh water, so salt water creates slightly more pressure. G means gravitational field strength. On Earth, gravity pulls liquids downward, giving them weight. For grade 7, we often use G is approximately 10 newtons per kilogram. Finally, H means depth below the surface of the liquid. Depth is very important. The deeper you go, the more liquid is above you. More liquid above means more weight pressing down. So, greater depth means greater pressure. Let's imagine a tall water tank. Near the surface, there is only a small amount of water above that point, so the pressure is low. Halfway down, there is more water above, so the pressure is greater. At the bottom, the entire column of water is above that point, so the pressure is greatest. This is why dams are built thicker at the bottom. The water near the bottom pushes harder against the dam wall than the water near the top. It is also why submarines need very strong bodies. Deep underwater, the pressure from the surrounding water becomes extremely large and acts from every direction. Now let's test this with a simple bottle experiment. Imagine a plastic bottle with 3 small holes. One near the top, one in the middle, and one near the bottom. When the bottle is filled with water, water comes out of all 3 holes. But the water from the bottom hole shoots out the farthest. Why? Because the bottom hole is at the greatest depth. Greater depth means greater liquid pressure. The middle hole has medium pressure, so the water travels a shorter distance. The top hole has the least pressure, so the water travels the shortest distance. We can also use a simple example with the formula. Suppose water has a density of 1,000 kilograms per cubic meter. Gravity is 10 newtons per kilogram, and the depth is 2 meters. Using the formula P equals RHOGH, we get P equals 1,000 times 10 times 2, so P equals 20,000 pascals. A pascal, written as Pa, is the unit of pressure. So at 2 meters deep in water, the liquid pressure is about 20,000 PA. At 4 meters deep, the pressure would be twice as large. P equals 1,000 times 10 times 4, which equals 40,000 tilons PA. So when depth doubles, liquid pressure doubles too. Mini recap. Pressure means force per unit area. The basic formula is P equals F divided by A. For liquids, the formula is P equals RHOGH. Liquid pressure increases with depth. Liquid pressure acts in all directions. Denser liquids create more pressure, and pressure is measured in pascals. That is why divers feel more pressure deeper underwater, dams are thicker at the bottom, and water from a lower hole in a bottle shoots out farther. Settings. Professional grade 7 educational video. Use clean classroom-style visuals, real-life media, and animated diagrams. Include a student diving in a pool with pressure increasing by depth, animated water tank with low, medium, high pressure labels, arrows showing liquid pressure acting in all directions, dam thicker at the bottom, and submarine with pressure arrows from all sides, and bottle experiment with 3 holes where the bottom stream travels farthest. Show formulas clearly on screen. P, R, F, A, P, R, R, G, H, P, R, 1000, X, 10X, 2, R, 20,000 PA, and P, R, 1000, X, 10X, 4, R, 40,000 PA. Calm professional narration, light academic background music, clear formula highlights.